All right, what's going on? Hey, Rico CZ and Zmoo and DPyre Roberts, how's it going? Hey, Rainbow Dynamics, how's it going? All right, everything looks good. So yeah, haven't streamed in a little bit, but I want to check out these new IDA 9.0 features, and we can reverse some malware with them. They're pretty good, like mostly quality of life improvements for the client. I've heard some different things in terms of like licensing. There's not going to be any more perpetual licensing, which a bunch of people have complained about on X and stuff like that. But I figured we could just look at the feature changes themselves instead of discussing the lack of perpetual licensing going forward, and then moving to a subscription model and stuff like that. Because like for me, obviously that isn't great, but if I can just keep 8.4 perpetually and then use 9.0 going forward with new features, I think that would be cool. But it just is what it is. So hey Leon, how's it going? Hey Andrew, nice to see you. Hey Sergey, what's going on? Yeah, it's November 3rd in places too, obviously. Hey Numpad, how's it going? Okay, so we can just like look at this blog post. Then there's like full docs on some of the 9.0 feature changes. So probably the biggest thing that I'm excited about is this like idalib thing. So that will basically allow you to do like headless IDA in a not crazy way with a bunch of command line arguments to IDA T like you used to have to do. And it makes kind of editing and messing around with the Python interface quite a bit better. Then there's risk 5, which is pretty cool. Obviously, you have to buy the decompiler separately with their current model, unless you get like IDA Ultimate or whatever. Nanomips. So these are, I think, risk 5 and nanomips were recently, or I think nanomips was recently added to Binja. I think risk 5 has been there for a bit. WASM is cool. So I've done some like CTFs where people were using WASM for their challenges, and debugging it was like horrible in the browser. So if you can disassemble the WASM structures, the WASM files, that would be extremely useful. So that's really cool. And then we're going to talk about some IDAPython changes that they made because it broke a bunch of stuff. I was looking at like HashDB, and I think they already did a port to 9.0, which is super cool. Let's see. Yeah, update 1.9.0 to IDA 9 support. So HashDB is already updated, but I think it's going to break like a whole bunch of different plugins that already exist, which sucks a lot. HashDB is, I can show you what it looks like, but it's basically a plugin to help recover strings associated with hashes that are commonly used by malware. And those hashes are typically used to dynamically resolve things like imports at runtime. And so they can just have hash values embedded in their database instead of strings. But that's kind of the gist of it. It's awesome because it's basically like a pre-computed rainbow table that basically, like if you look at this little GIF here, it lets you recover the associated string values associated with these imports, which is pretty neat. But okay, before I get super off track, like I'm already doing, there's no more IDA 32. So for those of you who have used IDA for a while, it was pretty crazy because for like 32-bit binaries, you had to use a completely different application, and then for 64-bit, you had to use a completely different application. So now everything's unified under one application, which is really nice. Their Flirt updates also look pretty interesting. I wanted to go over those because there's some kind of interesting new functionality, like applying Flirt signatures is a lot easier now. You don't have to do like the crazy multiple clicks to apply a single Flirt signature anymore and stuff. Metadata descriptors for plugins. I think they're basically trying to make like quality of life improvements for their plugin management system. because it's quite inferior to Binary Ninja in my opinion. FlirtDB now. I don't. Yeah, I'm not super familiar. Hey, Mishap, how's it going? With all the FlirtDB changes, or sorry, the Flirt changes, but we can go over those and see what they look like in the actual IDA application. So, okay, so yeah, that's the gist of it. One thing I did notice is that their docs have like improved substantially. So before I get into this stuff, I'm pretty sure there's IDA 9. But yeah, like there's actually a nice search interface, and then it'll pull up stuff like this. So, oh yeah, IDA 9 highlights. So it's like quite a bit better. And their like web UI is modern and not super old like it was before. So yeah, idalib, we're going to mess around with idalib today. I was messing around with it on my laptop, chilling on the couch watching movies today. So I wanted to show you guys kind of what that looks like. And then, yeah, we already went over some of the new decompilers and disassemblers. So this C++ exception support is really cool. So that was implemented by Rolf Rules. He put out a blog on that. Exceptions. So I'll link that because it's really good. Yeah, Andrew, it's going well. Good to see you. Leon, doing good, thanks. Let's see. Adam Vance, I'm actually interested how this differs from 8.3. So yeah, I'll go over that, Adam. And yeah, so what's really cool about this exception handling is now basically if you do have try-catch blocks within a C++ application, there's a bunch of artifacts that they can now recover and then literally show you the try-catch blocks, which is really cool. I'm not aware of any other reverse engineering application that can do that, so pretty cool. So yeah, they made some changes to IDAPySwitch. I'll go into kind of how to set this up on OS X. There's auto completion in the CLI now. So like if I pull up IDA, I just have like a piece of malware that we've kind of looked at in the past up here. Oh yeah, what I thought was funny now is they're doing like dark theme by default. And they're kind of trying to do a bunch of stuff that was in Binary Ninja. So they're kind of trying to reach feature parity with Binary Ninja, which I thought was kind of funny. But yeah, so if we do like IDA, so like idc.get, and then I hit tab, if this is too tiny for you guys, let me know. Then you can see this has the actual function definitions associated, not definitions, but maybe I don't know how to use this tooltip. Let's see, get B. See how this is get bitmask, but when I like hover over it, it disappears. So not great, but if you like get bytes and then tab, then it shows you the arguments. But it's still not as nice as Binary Ninja. But just to show you an example of what the autocomplete stuff is, is it pretty small? Okay, let me make it bigger. Okay, hopefully, I don't know if that'll improve the tooltip, but yeah, it didn't make the tooltip any bigger, but we don't have to worry about that right now. But yeah, this font size should be okay for reversing other stuff, but let me make all this stuff bigger, just so I don't have to worry about you guys not seeing it. This font doesn't look great, super big, but that's okay. Okay, so let's go back to the docs here. So the new virtual environment stuff is pretty good. I'll show you how that works because I found it to be pretty straightforward and easy to use. Let's see if there's anything else in here that I missed. UI improvements. So they like got rid of the old struct and enum menus. It's like a unified type manager now. So if I go to local types, then this is all unified in one area now. One of the big things that I noticed, so before you would have to like buy a specific operating system version of IDA and then you couldn't switch off of that. So it was like, it was really bad because say you wanted to use Linux, say you wanted to use Windows, say you wanted to use macOS, whatever, then you would have to literally buy, or you'd have to like move your license over to that. So one of the biggest things for IDA 9 was them allowing you to download any version of IDA you wanted in terms of like operating system support. And then, so that's why I just installed this on macOS. In terms of licensing, I still have my perpetual license, and then it's up for renewal in like, I don't know, this month. So I'm interested to see what the cost is going to be, because a few people were mentioning that the cost went up quite a bit. But yeah, so, but right now I'm in like the trial period, and that didn't affect like getting IDA 9 didn't affect my perpetual license going forward. So I just figured we could try it out today. Okay, let's check out the chat. Igor probably did it on the plane, like every nice UI feature added. Yeah. How do I make it show suggestions for the command completion again? Doesn't show up on my IDE. So tester of reverse, you can actually I can show you that real quick, because I was gonna show you how to set up the Python environment anyways for the headless mode. But like if you're using VS Code, you can add these like Python analysis extra paths, and then you can just add the IDAPython path, and then if I do like let's just do like test.py, then I can do like import. It would help if I could type import IDC, and then you can do like idc.get, and then it'll like autocomplete and then show you the docs. So that's how you do that. Oh yeah, in IDA, it's just like a tab. So when you're typing into, let me switch back here. So if you're typing into like the Python console interface, you could just do the same thing. So like idc.get, and then tab, and then it shows you here. So hopefully that makes sense. Yeah, I have my keyboard on a weird angle, so I think that's why I was not able to type. Okay, what else? So yeah, so unified structs and enums now, so those aren't separate, which is cool. We went over the Python improvements, and we're gonna mess around with that soon. Okay, so there's like IDA plugin.json, and it offers an entry point for plugins. Okay, I think that this just affects the way that you develop plugins. Processor modules. Okay, so this is just kind of giving more descriptions of supported stuff now. Looks like they made some Mach-O changes, which are welcome. And I did notice I could download the SDK, so I don't know if I could do that before, but now I can get like the Flare tooling to generate Flirt signatures, and that's just with like a standard license, which is cool. But yeah, let's look at these in IDA. So you can self-contain the plugin in a folder without needing the Python file directly. Oh, okay, cool. Yeah, that makes sense. So it's just like the ability to specify where you want your files, essentially, in that JSON file, I guess. Hopefully that was correct what I just said. Okay, so what I wanted to do next is just kind of show you how you can set up a Python environment with IDA now. So on Mac, you have like the .idapro, which is in like my home directory. But if I go to /applications, IDA 9.0, and go to contents, then macOS, then we have a whole bunch of different files. So similarly, they've kind of cleaned up a bunch of extra stuff that they had before. Again, they don't have the two separate versions of IDA anymore. But if we go to Python, then and go to examples, they still have a bunch of this stuff. When I was doing that Hexray stream, I probably should have looked at the Hexrays folder on here for IDAPython examples. But if I go to, I think it's libIDA or idalib. Yeah, idalib. If this is too small, let me know. But, and then go to the Python directory. Then this is the headless library that you need to install within your Python virtual environment. So if I'm just going to make another tab here. So if I go to I'm just going to put my virtual environment in this idapro directory. So we'll do Python venv, and then we'll just do env. And this is Python 3. And then, so we're in a virtual environment now, and then I'm just going to activate this. So we've activated a virtual environment. And then if I want to install the headless IDA stuff, I just have to go to back to the IDA directory. Okay, and then we go to Python, and then, so this is within my activated virtual environment. So if I do like which Python, then this is in that virtual environment, and same with pip and stuff. So like which pip, then same thing, it's in my virtual environment. So, but if I want to install this, literally all I have to do is pip install here, and then so that installed idapro. And then I definitely need to update my pip version, super old on here, but that's okay. And then I think I have to do Python py-activate idalib as well. Run py-activate idalib, utility shipped with it in order to activate this module. Okay, it's here. So let's try that again. So the Python, as you can see, this user, like the Binja one actually works just a lot better than this, but we'll deal with it. So I'm just gonna do Python idalib, Python activate, py-activate. So I think that's all we need, and then now I can do Python import idapro. Okay, so that's working. So that's basically how you set up the new headless mode. And then, as I mentioned earlier in my IDE, I just added the search paths. So if I make this a little bit bigger, I just added the Python analysis extra paths to my VS Code. And then so it can find the IDAPython as well, in addition to that. And in order for us to be able to run this within that new virtual environment that I just made, then I'm just going to set the virtual environment path here. So I'll do, okay, there we go, that fixed it. I thought that was aliased, but okay, so now say we wanted to like analyze a file with IDA headlessly, right? Then we can literally just do import idapro, and then I think it was idapro dot, there's an example file that I might open. I didn't really want to do that, but that's okay. Okay, so they have this example in the IDA9 Python directory, or the lib IDA directory, and it's pretty straightforward. Like all you have to do is, if you want to open up a file, you just do idapro.open database, and you don't only do that for a database, you also do that for a file. So it's kind of a silly naming convention, but once you do that, you can create an undo point, which I thought was funny. But basically that allows you to revert changes before you do them. And then you can do things like execute a script file from this interface. You can do, you can apply flirt signatures to the IDA database, et cetera, and then you can like close it and stuff like that. So if I go back to where we were before, so we had test.py, and then we'll do idapro dot, all right, we're back in business. So idapro dot open database, and then we can just provide like a specified path. So let's just do like sys.argv1, and then let's try the script. So stream, oh wait, we want stream notes IDA9. Okay, so if I do Python 3 test.py, and then I'll just get a random, or the piece of malware that I wanted to look at today, Syscall. And then we'll do second stage DLL. Would I have to activate this again? I don't see why I would, but all right, so this part sucks, but so I'm just gonna activate that again. I don't really know why I need to, but why isn't this working? Could not find file. Oh, it's because I'm not specifying it. I think it's working now, hopefully. Could not find name in root directory. I don't know why this is doing this. This wasn't doing this earlier on my other laptop. Okay, let's catch up with chat and I'll fix this. Still nuts to me how they're changing, or sorry, how they're charging per compiler, especially as they still split 32 and 64-bit for local, even with subscription models now. Then again, it's probably mostly companies paying for it and not individuals. Yeah, I agree. Like with Binary Ninja, it's just very little comparison, right? It's also crazy how they're shipping unpassworded installers with all the decompilers and no watermarking. Miss up. To be honest, I'm happy staying with Binja for now with student discounting. Yeah. I primarily use Binja now. I still use IDA for some stuff that it's better at, but okay, let's try. I don't really know what else to do here. Do we need to be, please make sure you have the IDA. Maybe I have to do that from here. I doubt it, but contents, macOS. Okay, there we go. Now, will that work? Please work. Oh, and then we need to do run auto analysis. So I think this can just be like a Boolean. So this is just going to automatically analyze the database. Database initialization failed with error 4. Okay. I don't know why. Maybe it's because I have this open already. So maybe let's do one of the other samples that I don't have an IDA database for. Yeah, I think that's probably the issue here. Okay, I think I have NTDLL in here. So let's do that. And I think it's getting symbols, which is why my firewall is prompting for that. Is it okay to use the headless IDAPython module new to IDA scripting? What do you mean, is it okay to use it? I think it's okay to use it. I'm using it right now. So this is currently analyzing. This isn't really going to do much for us because it's basically just analyzing NTDLL. But I'm going to show you some stuff we can do. So what's interesting is this is like a global state. So like once I've opened the database, then I can do like, let me do like IDA utils. And I think it's just like IDA utils dot entries. And then I'll just like print this. And I'm just going to kill this because we don't really need it. And then if I run this on, maybe I can run this on some malware. So let's do like, oh, headless IDA. Oh, I don't think I've used that before actually. I think this is basically like trying to replace the headless IDA project. Let's check it out. I like the icon. Headless IDA path. Cool. Yeah, I've never used this before, but that's pretty neat. I'm assuming it just calls out to IDAT 64 or whatever. That's nice. I think, yeah, basically this is like a replacement for that from Hexarys. I don't know why this is taking so long. I wonder if there's like a verbose output option. Yeah, it's definitely analyzing it. I don't think this file is that big though. So it has those IDA files, so it's definitely working. Yeah, it's like 38K, so it's not very big. Okay, well, while I'm waiting for that, I'm just going to show you something I wrote earlier that's actually sort of useful. What's cool about like having the headless mode is we can do stuff like programmatically, obviously. So anything that we do within our IDA console, we can automate that and then run it against like as many files as we want headlessly. So it's a lot better than having to like open the database and then run a script against it, etc. So a good application for this, or we can look at something in this sample that it has a good application for this. So for those of you who have been watching the streams for a bit, you might remember that we did a whole series on analyzing CACbot. So here, I have, for those of you who are not super familiar with Invoke, I put all the streams up on YouTube afterwards, including this one. So this is the stream series that we did on, or we analyzed CACbot with. And when we did that, it was interesting because they're using this crypter called Dave crypter, and which is pretty widely used for some of the commodity malware variants that are sold. And what was cool about this particular sample is, or this particular packer that we were analyzing, or this variant of this packer, was it wasn't only dropping CACbot, but it was also dropping this interesting sample that was doing direct Syscalls. So that's what I wanted to look at today, is that same sample, because I never figured out what malware variant this was. So I figured that would be like a fun task for us to do today, and then mess around with some of the IDA9 features. So upon entry of so this is a DLL, and there's just a jump from this DLL entry point here, and then looking at this right away, we can see, okay, there's some value here that's passed to this sub 180000163, and then it has this 3064. So we want to look at this function, obviously, and then right away there's some interesting stuff. So on the left hand side here, we can see this move operation, and then there's just like a whole bunch of nops. So this is obviously like kind of a nop sled in the disassembled instructions, and then there's a call. And what's nice about the decompiler is it basically removes all of that, and then just shows us this set of instructions. So it handles all of those nops for us. So if we want to look at kind of what this is doing, so this value is assigned to this global. So if I look at the cross references for this global, we can see it's being accessed here. And then there's this call to this sub 180000100F function. And then there's a direct syscall that's made here. Again, kind of separated by these nops. I think this was just like a obfuscation technique that they were trying to use to maybe try and make some of this analysis harder, but the decompiler handles all this. But since we have a direct syscall here, we're probably dealing with some direct syscall stuff, which is quite interesting. And then, and so for those of you who are not aware, this is a common tactic that's used by malware variants to avoid common userland hooks that are implemented by things like EDRs and antivirus software. And they'll often hook userland API calls in order to intercept them, such as doing memory allocations, doing code execution functions that like different shell execute functions, whatever, anything you can think of that could be indicative of malice, antivirus software, sandboxes, all these things that have userland components will hook those userland APIs in order to try and intercept what the application is doing and determine if it's malware. So when you're doing direct syscalls, and what they're doing here is dynamic syscall number resolution, is you're bypassing all of that. So if you're able to resolve a syscall directly, then they're just performing the syscall directly here, and then they essentially bypass any potential for any hooks that are implemented. This obviously differs from kernel and security stuff that will intercept direct security calls. They'll typically do that through a filter driver that will essentially look for different userland calls into the kernel and things like that. I'm not really a kernel developer, so I can't really speak super well to that, but I do know it's a filter driver that will basically look at these sorts of things. So that doesn't really apply to this technique. So tester of reverse question, why won't IDA show what the syscall is doing? I like to see the value that's pushed onto the Syscall to be able to show what action the Syscall will perform. But all it's showing is, yeah. No, that's a good question. So what's happening here is they're actually resolving the Syscall number dynamically. So this is a lot more stable because if you have like differing, you can trace, you can try trace for kernel viz. Dtrace, like what you did in your DEFCON stuff, or what? But yeah, hopefully that makes sense. Tester reverse. I'm going to show you how they dynamically resolve these Syscall numbers here. Dtrace, yeah. That was a really cool part of your training. I do know, was it Mishap who? No, I don't think it was Mishap. Dtrace. Sergey, what was that project? So you have it on your Patreon. Oh yeah, Degenerate. That's what it was. Degenerate. I don't know if I'll be able to find this very fast. Degenerate from Jonas. Yeah, this thing. So good. Okay, I'll link you guys the tweet so that it's not just the. But yeah, this thing's sweet. No, it's okay. Don't apologize. But yeah, this thing's awesome. That Jonas wrote, because the dtrace interface is pretty crazy to develop for. But this can intercept kernel calls on Windows with dtrace, which is really cool. So yeah, that's a really useful project. Sergey's workshop at DEF CON was also really cool, by the way. Fortunately, I was able to be there in person, so that was nice. Okay, so let's get back to the sample and look at how they're doing this dynamic Syscall number resolution. So if I go to, so this global is being passed as an argument. And then if we look at the value that's being assigned, it's this hash looking value, right? So that looks very much like a hash. So let's just call this G hash. And then let's see what this is doing. So if we look here, we can see, okay, this is iterating over these D words. If we look at these D words, we can see that so this is a weird syntax in IDA, but 3EAH is, and then dupe 0 means that there's a hex 3EA zeros. So if I do undo, then there's just a 1 followed by all these zeros. So obviously this is some sort of table probably that hasn't been populated yet, probably a hash table. And then it's going to iterate for this amount of D words, which is, let's see where this is initialized. So it's initialized in this other loop. But if I go back here, actually, no, that was a good place to look. Entries. But if we look at where that's initialized, then we can see this belongs to, so you'll already notice that there is some very common dynamic function resolution being done here, and the IDD compiler is really good at resolving a lot of these struct members. Yeah, Leon, I'll answer your question in just a sec. Or not, I will comment on your comment / question in just a sec. But basically this is doing, so this will grab the PEB. So on 64-bit, the PEB is acquired from GS60. So this is like a magic value that is being accessed with the GS register. And that's moved into RAX. And then that PEB address is used to access the loader entry. And then that's used to access the in load order module list with the flink and blink linked list nodes. So they're basically walking this in load order module list linked list. And then they are, comparing these integer values. So if I hit R on these, that's just spaces because it's hex 20. But if I hit R on this, then we can see that this is ntdll.dll. So then if I hit R on these, we can see this is looking for ZW. Not entirely sure what that's looking for exactly, but it's probably the beginning of a function name. And then, sorry, let me just, I don't want to go too fast. So if the flink node value matches this ZW start, then it goes into this if statement. And then we have this function call here. So sub 18000 100A. So if I go there, then we can see that there's another call, and then there's this very hash looking like function here. So if I hit H on this negative value, then we can see, okay, there's this constant that's moved into this v3 variable. And then that is being used within this while loop. And on each iteration of this while loop, it is getting a byte from this first argument that's passed to this function. And then this is an index that's updated on each loop iteration. And then that is accessing a relative byte from this offset. And then that this while loop condition is just ensuring that there is not a null byte, which this is probably iterating over a C string. So it is terminated by a null byte. And then the each loop iteration will basically take a word from the relative offset of the index v4. It'll set that word into v2, and then it'll use it in this hashing XOR line here. So, okay, so this is probably a hashing algorithm that's looping over every function using this dynamic function resolution stuff. So once it finds NTDLL, then this is going to be accessing the the entry for NTDLL, and then acquiring the function name. This is going to be walking the export directory for NTDLL, and then once it acquires a function name that starts with ZW, then it passes that function name to our hashing function. So I'm just going to call this MW calls hash, and then so if I F5 this, it'll update that, and then let's just call this MW hash, and then this is going to be our hash table here. So, so Leon, so the Rust decompiler in Binja is kind of interesting because they're basically using the decompiler output, the high-level intermediate language, to kind of decorate the decompiler output like Rust, but it's not really a true Rust decompiler in my opinion, from what I saw. They open source the code. I could go find the code, but from what I saw, it looks good. Like I used it on a Rust sample and it looks pretty good. But yeah, that's Cindy, who's hangs out in here sometimes, has a better understanding of it. Xerox Zero Day. Hey, how's it going? Add the types / struct, and it'll clean that up. Yeah, so we can do that real quick. So if I have the flink structure here, the 7th offset will be the hold on, let me grab the structs here. Oh, it might be a plugin. Yeah. If you want to fix the list entry crap, you have to do the shifted pointer crap. Okay, yeah, I'll just leave it then. Yeah, I don't really want to do that right now because it's a pain. I've done it before though, but these should be easy to mark up. Like I should just be able to mark up what this 6th struct is. Like, was that a initialization order list and memory order lengths? Yeah, I don't think that's the right struct. I have a gist with it. Yeah, it's all good, man. All right, let's see this stuff. Okay, so it should be here, but this is gonna be different because it's 32-bit, but that's okay. Okay, so we have the list, the flink and blink, and that goes to the loader data table entry. So that's what I thought I was applying. But yeah, we get the gist of it. So okay, so and then it's iterating over the hash table entries, and then it looks like it's just populating this hash table with all the ZW function names. And then this, I think this is just counting the hash table entries, most likely. And then this V9, or maybe this is actually getting the Syscalls. 2, 3, MW gen hash table. And then we can take a look at the actual NTDLL functions to see if the actual syscall offsets are this close, because then these hash table entries are actually going to be quite unique in that they'll have each syscall number for each resolved function. All right, let's do the headless stuff that I want to show you guys, and we can probably fix up these offsets afterwards once I know exactly what they are. But basically it's acquiring this entry 1 value, and then it's assigning it to the 4th entry value. So I'm not entirely sure why that would be occurring, but it'll probably make more sense once we reverse more of this. And once I actually mark these offsets up correctly, because I'm assuming this is the beginning of export table, which I have in my slides here. Yeah, the image export directory, but it's not walking that. It's just accessing it down here relative to the F link. So I'll need to figure out what this is, but okay. So kind of what I wanted to do is, so this is actually not in HashDB. And I know I can add it to HashDB, but I thought it'd be fun to try some of the headless stuff and generate the hashes ourselves, and then just make an enum that we can just import into this project. So if I go back here, I'm just going to mark up each of these call sites so that, so this hash entry 0, so it'll be our target hash, and then so we generate all the hash tables. If that fails, so if a -1 is returned, then we return. But if it doesn't, then we look through all the hashes that were generated in the hash table. So that makes sense. Then we have a jump to that. By the way, I recommend using, are the built-in ones not correct printup? Will this IDC script just like do it all for me? Should I just run random IDC that I found on GitHub? So I can just add these to our directory. Okay, I'm going to copy the TILs to IDA into the TIL directory. Is that all I have to do? Under the PC one, right? All right, and I'm assuming I am going to have to restart IDA. Oh, cool. Okay. Place in whatever the macOS equivalent is. Okay, so I can do it locally too then. Well, I did it that way. I know the way you said is better, because if I get a new version of IDA or whatever, you have to load the type lib. All right. Okay, and then I'm just going to find these guys. The 64-bit one is what we need, but I'm just going to load both. Actually, yeah. All right, now I can be adding the local types. Loader data table entry. Okay, so I'm assuming we want loader data with table entry and not the 32-bit version. Cool. All right, let's see if that helps at all. Thanks, printup. Appreciate it. Okay, let's try. No, it's the same thing. It must be a different struct. Unless these F-link entries are different than what I remember. Manually importing, you can skip manually importing, what? Oh, it's because of the shifted pointers. All right, let's, I'll grab that later. We should be able to get these the list entry flink blink points to the other. Oh, okay. Okay, let me look at the shifted pointers. But yeah, before I bore all of you to death with these struct reconstructions, I just wanted to show you the new stuff with the headless mode. So, okay, so like in theory is if this is all the NTDLL hashes that it's resolving dynamically through this call, then we should be able to re-implement this hashing algorithm in order to determine what hashes are being resolved here. So if I go to the hash call here, we can re-implement this. And I already did this today, so we don't have to worry about redoing it. And then look at this hash export script. We have our hash exports script here. And all I'm doing is, all I did here is I have the hashing algorithm re-implemented here. So literally all it's doing is it has this hash constant, and then it's iterating over a byte array. Well, in this case, it's a string that I convert to a byte array using this bytes call. And then I'm acquiring the first word from the relative current index, which is stored in v4. And then I'm just doing that hashing step and then creating the hash here. So, and what's cool about this is I'm using the new like headless stuff. So I'm doing like IDAPro open database, and then I do this get exports call. And then for each of the entries, for each of the export entries that are resolved by IDA, I know I could use PE file and a number of other tools to do this. But for each entry, I'm acquiring the ordinal, the address, and the name, which is what's acquired in this IDA utils call here from the IDA database, and then I'm returning that. And then for each of the functions that are hashed, I'm just creating a large enum here. So with all the resolved hash names. So if I call this, if I execute this script, and then syscall, and okay, so I'm going to call hash. So I'm just going to remove all of these IDA files because I guess it's okay. So test or hash exports, and then provide NTDLL, then we should get a hash list. And then I'm going to go through the chat. Okay, so yeah, let's check out the shifted pointer stuff that Sergey did. Okay, the flink and blink. The process of walking the PEB is to access the module loaded. Yep. Okay, accessing via its list entry, and the PEB loader creates a very messy IDB. Instead of the loader data table entry members, we see unhelpful offsets relative to flink and blink. The reason this happened is the list entry and the PEB. Okay. This is very nice, Sergey. Okay, so let me I don't know what people think, but I would love to see the process of implementing the algorithm identified in the malware. Seeing the development process from scratch gives a lot of insights. Yeah, I can re-implement it. I know it gets longer, but it's great to watch. Yeah, sure. We can do that. To use some fancy keyboard or something regular, I'm just using the Mac Pro that I'm using came with like a fancy Apple keyboard, so I'm using that. But it's pretty standard. Yeah, I guess we don't know how to fix those types of structs. Question is whether it matters or not. I'm guessing most people won't care. I guess in your case, the offset will be hex 10 instead of hex 8 pointer size. Yeah, no, I think it is important print up because like obviously I knew that this would be the full DLL name in this instance. But there's other offsets there that I do need to fix in order to understand what's being integrated into that hash table. Okay, so if we want to re-implement this, I can do that while this is running. Maybe I'll just open ntdll. I don't know why this is taking forever. It was not taking that long on my other laptop. I'll open that in IDA. It might have been querying the symbol server. That's probably why. And applying all the symbols. So basically all I'm doing is opening ntdll directly, because literally all we need is the export names, which it doesn't need the symbols for. Now it's applying the Lumina stuff. That's okay. No, don't worry about regretting it. It's a good exercise. Okay, we don't need Lumina stuff applied. So, okay, so I'm going to save this IDB, close it, and then there we go. Okay, so this is the hashes within a big enum, but I'm just going to show you kind of how I got to that point, since 0 Day was asking about it. So, okay, so basically what I'll typically do, so looking at this hashing algorithm, or what we believe to be a hashing algorithm, to re-implement this in Python, it's not too difficult. The weird thing in this case is that at the beginning of the string, it's accessing this word. So that's the only kind of weird thing in this instance. Otherwise, we can kind of use this verbatim. But if we wanted to re-implement this, we could do something like copy out the pseudocode and then this guy, and just use this as a reference. So we have our entries there, but let's just do def hash, and then we have our string here. So I string, or let's just do E string for export. And then we have v4, which is initialized to 0, v3, which is initialized to our seed value. And then we have our while loop here. So we can just do like for I in range 0 to the length of our input string here. And then for each index within that string, then we're going to be getting a word value. So v2 is equal to e string I to I plus 2. So that'll get the slice. And then I think that should work. And then v3 is XORed with this kind of nested bitwise logic. So we just do like v3 shift by shift left 24, and then or. Luckily, like the C syntax in this instance is quite similar, so we don't have to worry about it too much. And then, but if you get into like roles and stuff like that, you have to do this a little bit differently. But fortunately, in this instance, this algorithm is pretty straightforward. And the result in this instance is going to be an integer. So we actually want this to be, and then this is cast to 64-bit int. Or a keyword. So we could do that here if we really wanted to. So with Python, it's kind of awkward. You have to use like bit masks because it's these are all just objects. So they don't have like actual data sizes like strongly typed languages. So 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4, 5, 6, 7, 8. To make that a keyword. Which is gross. And then I think this whole result of the v3 XOR, I think we just have to end it with 2, 3, 4 to make it a unsigned integer which is this is like obviously IDA's interpretation in the decompiler. So you don't always want to take it verbatim, but it uses the register sizes and stuff like that to infer that this is an unsigned integer. But that is accurate in this instance. So that's basically it. And then we can return v3. And then for each of those entries, we can do that. So for v2, you can do int. Oh, cool. Int from bytes. And then the range will be, oh yeah, because this is going to be in 2 bytes, or like the slice, right? So 2 int dot from bytes. Thanks, printf. I think that should work. Let's see. Then we'll call the hash here, and then print it, and then we'll just do the name. So E, and then E will be, again, each entry is going to be the what did I have before? So each entry is going to be like, so if I open IDA here, we can do this. So like IDA utils. Oh, I have to import IDA utils. And then we can do IDA utils dot entries, and then that's a generator. So then we can just do like a list, and then so each entry each entry within the entries generator has these four tuples. Like, I don't know if that's the correct term, but so then we just need to assign that on each iteration. So if I pull up the code here, then each entry is going to have, let's see, so it's I think this is the ordinal, the address. I don't know why the address is there twice. Maybe it's different. And then the name. And then we just want the name. And then the name here as well. Check out the chat. This all goes a bit weird though. I would check if they're passing a Unicode string or C string. The while condition makes me think it's a regular C string. Yeah, so I think it is a regular C string. Oh yeah, I forgot to update 4. Thanks. v4 plus equals 1. So yeah, 0 day. Hopefully that provides some clarity as to how I implemented it earlier. It was pretty easy in this instance just because it was like almost like a 1-for-1 mapping from the decompiler to the Python, except for this int from bytes. That's kind of weird. But basically this is taking 2 bytes and then deriving an integer from the word. So then if I do that, we have to go back to my stream directory, and then Python, and then we're going to provide our IDB and then our ntdll IDB. So this is a very roundabout way of doing this, but that's okay. It's just like a kind of silly example of what we can do. I think it was just because I have to reopen it with IDA. So as you can see, this user experience isn't the greatest yet. Okay, so I'm going to close this database correctly. Holy crap. All right, and then we have to convert that to bytes, which I did not do. Okay, so then we have the E string, bytes E string, and then I think that should be sufficient. Let's see, bytes. Oh, it's going to be ASCII, and I know printf, you're saying this could be a wide string, but it's not in this instance. So, or I know what you mean, because it could be a different. The hash could be different if it was a wide string, but I tested this out earlier and it was the correct hash, so it was okay. This could be ASCII. Okay. So yeah, here's our hashes. So So hopefully that was estring.encode would be preferred. The Binary Ninja free version, any good? How does it compare to IDA and Ghidra? So yeah, the Binary Ninja free version is pretty good, I think. I would just try it out, to be honest. It has the decompiler in there, and I think it only has 2 architectures, but it has like, here I can just pull it up. Purchase, non-commercial. So yeah, it has 4 architectures, which is pretty crazy. ARM v7, and then 4 file formats. So PE is in there too. So yeah, I would just try it out, but it's pretty cool that you get like a decompiler in the free version. Obviously there's restrictions for use, but if you're a student as well, it's like $74, which is really good. Yeah, I just got Sauce Boy. I started using the 2x thing just because the format string is pretty useful. Also, Zuni, we have like Binary Ninja training, and you get a free license with it. Well, free because obviously the training costs money, but we just did a Binary Ninja training course for malware analysis, and you get it includes a license with the purchase. So yeah. Okay, so we re-implemented the hashing algorithm. I'm just going to continue using my other script just because it had, I guess we could just redo the enum syntax. It's probably not a big deal. So let's do print enum hashes, and then \t name equals, and then print. All right, and then so that should give us an enum. And we'll fix up the last entry. I was just being lazy. Okay. So now we have a header file. Then I'm going to copy this into IDA. I'm kind of new to RE, to be honest. I have no idea where to start, but I find it interesting. I know a little bit of C and C++ and assembly. Yeah. Yeah, it's like these streams, all like the free material that we've put out. We have like a YouTube channel as well if you're interested. Like all these streams and stuff on our YouTube, auto playing videos. This is all free if you want to check it out, in addition to the core stuff. But yeah, joining stuff like this is a great way to learn, so you're doing all the right stuff. Print up, by the way, you can do hash name. Oh, cool. Okay, so I have the, and then I just need to go into the new types menu again because there's no enums menu anymore. And I'll add this type. Let's just call this ntdl hashes. And then if we go back here to that global hash, this thing that we saw earlier, then I hit the M key. Now we can see this hash corresponds to ZW allocate virtual memory. So effectively, this function being resolved here is the syscall for ZW allocate virtual memory, which is like kind of an alias for NT allocate virtual memory. So, and then we kind of did that with headless IDA, which was sort of cool. So if we had like any other given DLL, we could hash the exports for that DLL and then get an enum from it, which is kind of cool. Okay, so I think there's other hashes in here we can resolve with that ntdll enum. But I'll just say MW allocate virtual memory, and then so it makes a memory allocation, then it does a jump out here, which IDA can't handle apparently, so let's see why. Into this 1765 address, into these CCs, which if I make, it's like a whole bunch of int3 interrupts. So this is probably like anti-debugging stuff. And then that eventually leads to this code, I think, which has another hash. Okay, which isn't in our list apparently. So if I go here, ZW allocate virtual memory. Yeah, I wonder what this int3 is doing. But I think this might just be our size. And then, or no, this is probably the size. And then this is being, what's the third argument to, let's see, ZW allocate virtual memory. We have the handle, a base address, the region size, allocation type, and protect. So if we go back here, then we're going to have, I'm assuming these map one-to-one, but -1 process handle, base address, 0 bits, region size. Then we have allocation type. So this should be in our enums, hopefully. Mem underscore, maybe not. And then 64, which is the protect. Maybe they're not one-to-one argument mappings. And then, so I think there's code that I'm missing here. So it calls that the return values in here. So memory allocation. And then we have this value that's loaded into RCX. I don't know why the decompiler removed all of this, but it's obviously very important. So, so this is probably, maybe this is more code. And call, okay. So it's getting so it's pushing 430, then it's getting the current location that it puts into RCX. So, okay, so I should probably explain what I'm doing. Then it'll be fine. Okay. It's just like underscore tail call or something. Print up, help me. Can I just edit the function properties? Why did they hide so much stuff now in this menu? Tail call. Okay, hold on. I just failed to recognize the call was a tail call, so no return required. Wait, never mind. It was a call instructions, not jump. Oops. Okay, never mind. Sorry. What malware is this, by the way? Sauceboy. We're trying to figure that out, actually. So, okay. Automod didn't like that you said the word, that word, so, but I allowed it. Okay, so, all right, so we have that allocation. We can just use the disassembly, so that's okay. Memory allocation, and then we have a jump. So if it's greater than or equal to 0, then we have this move operation. Then we have our region size that's compared. Okay, this is fine. And then we have our base address that's called. So I believe it's just calling that code. So let's take a look here at that location again. Where's the code I just saw earlier? Let's see. Jump. Where was it? I just saw it. Okay, we have an add and return. So, okay. All right, yeah, looks pretty straightforward. Where's that code blob that I saw earlier? Here we go. Okay, so we have this and is to make room on the stack. Again, we have our location, and then we're calling RCX again. RDX would have the value of 430, so 430 plus A is 430 plus hex A, 1B8, and then so that'll be relative to here. So it would be, so okay, I'll explain to you guys what I'm doing in just a sec. No, give me the actual address here. Okay, so just to give you an idea of what I'm doing. So the virtual allocation happens, and then this position independent code is called. So this is using a bunch of typical shellcode tricks where like it zeroes out RAX, it pushes it onto the stack, it pushes RSP onto the stack. it pushes 430 onto the stack, but then it pops it off the stack. So all this is just a write into RDX with the value 430, and then it's doing a call for the relative offset +5, and all this is doing is it's jumping. It's doing a call to the next instruction, and then it pops that. Since the call occurs, it pushes the current return address onto the stack. And then since it has that address on the stack and it pops it off into RCX, all this is doing is getting the address of this entry here. And then it's adding RDX here, which is 430. And then it's adding hex A to that address and then calling it. So all I did down here was I added 430 to hex A plus the address of our, oh, sorry, I calculated this wrong. So I just added up all those addresses together, and then this relative offset, and then this should be our call site, I believe. Maybe, maybe not. Ret address 5, yeah, okay, 5FD, 5FD4. Oh, it's the pop address. Oh, okay, cool. Because it's is it because of the +5, which is the size? So if I get the instructions, yeah. So 1, 2, 3, 4, 5. So it'd be this one, right? Print up. Okay, so let me get rid of that and go here. Okay, so then it's doing this. Like this is gonna be a giant pain in the ass. So we might want to like emulate this or something. Or execute this dynamically. But basically it's going to keep doing these calculations, but let's just do this one manually again. So it'll be, this pop. So it'll be this plus, this plus, 0C. So I think this should be it. And then, okay, so now we get some calls here, which is good. So we don't have to keep doing that. Okay, so we get 2 calls to this function. And then this is resolving the PEB again. And then getting the process heap. And then it's getting, let's see, what's this doing? It looks like it's just copying some value onto the heap. And then this is another call here for a hash that we don't have. So let's figure out what this DLL is. Okay, so I think this is the, okay, it's looking at the PE. Yeah. Should I just, yeah, well, I'll just generate all the hashes, right, for that. But I need a copy of kernel 32, but I can get that from my VM. So if it's an MZ, PEB loader data, I think this struct offset is incorrect as well, but that's okay. And it's a PE. I thought this would be a specific DLL name again, but this is invalid ASCII, and then that's just looking for the PE header, because this is being passed to, I should probably figure out what these structs are. Yeah, it looks like it might be different. 0, 1, 2, so then we have, so it might just be NTDL again. Sauce Boy, so like a long time ago, I looked at this packer that CACBot was using, and then we wrote some automation to unpack a bunch of those pack samples, and then I found this piece of malware. So it was like Dave Crypter, and then it resulted in this DLL that I'm trying to figure out what it is. And then now this is a different hashing algorithm, so we're gonna have to re-implement this one, which is always fun. But this might just be NTDLL again. But yeah, this is, I think this would be the image export directory on, and then these offsets differ because it's 64-bit. But let me double check that. I'm not used to them. But basically this is walking the export directory for this structure, but I'll need to figure out the 64-bit offsets. Okay, so we have a byte array, So we can do the same thing as before. And then we'll do v1. And then we'll get each byte again for I in range. We'll do that again. And then we have v2 is equal to 401, v2 plus v1, XORed with. I hope there's not like a million of these hashing algorithms throughout the piece of malware, but there might be like different variations. And then we have, make sure our brackets are okay, so that is doing them in the correct order. And then I think v2 needs to be our current index. So a1 is going to be our current byte, or v1 rather. And then there's a nice interactable website you can use. Oh, cool. Sweet, I'll check that out. Yeah, the image optional header 64 is what I needed. That's cool. Thanks, printup. I'm just rusty with 64-bit, to be honest. Okay. Let me just make sure this is right. And then I is going to increment on each iteration, but it's doing, like, does it just skip over the first character? Oh no, it doesn't. It does it up here. The decompiler is doing like crazy stuff. And then let's make this a 32-bit int. So, all right, let's see if that yields anything for us. But let's see, ESTRB, okay, 1, yeah, okay. And then the final one is v2. Yeah, that looks okay to me. And then let's make this, okay. And then we'll do #2 down here. Hashes 2. I always forget the encoding on bytes. v2 is reference before assignment. All right, I'll import this into IDA after fixing up this crap that I'm too lazy to. We want both of them in here just in case. And then add type hashes.h. Okay, so now we have both hashes 2. Okay, whatever. I'll figure that out later. I don't know why that's like they're two separate enum names. I don't know why it's saying that they're type deft, but #2. Okay, so let's see if okay, this is called in a bunch of places, but we don't have the hashes for them. So this could be a different DLL. So we got to figure out what DLL this is, unless I implemented the hashing algorithm wrong, which is a possibility. Okay, so let's go back. So we definitely want to figure out what DLL this is, and we should be able to. v4 check PE. Maybe this 64 is or this 3BF is the less than or equal to 3BF. But would that just be the number of entries? PEB, current PEB, in initialization order module list, but in initialization order. So does that mean it's ordered? It's an ordered list, and then, man, these tricks are pretty crazy. Like, how can I figure out what DLL entry that is? Like, obviously by understanding the code better, and then, but is this just looking for a particular entry? All right, sounds good. Take care, 0 day. Maybe I should run this dynamically. I don't want to, but the is getting a little bit too annoying for static analysis. But yeah, I'm gonna do, I drank a bunch of water, so I'm just gonna go for a quick bathroom break, but I'll be right back. But if you have any questions, shoot them in the chat and I can answer them when I'm back. So be right back. Okay, so I think I'm gonna run this deal dynamically. I know there's some anti-analysis stuff, but we'll just deal with it. Because yeah, it's getting a little bit too much of a pain for static. At least it might be a little bit faster if I can just like be like, okay, this DLL is being resolved, etc. But we made it pretty far with static analysis alone. So let's do this. I'm just going to put this sample on this box. Okay, so we're going to hit the entry point. Let me just take a quick snapshot so I don't have to put this deal back on the box just in case we lose it or something. Yeah, like I've been getting the perpetual license for a while now, and that's that helps with the cost, because if you renew every year, then it's like a lot less. So I'm just going to rebase my IDA database to be the same as our DLL in memory here. And then I'm just going to go to the entry point, see if we can get to like around the same spot that we're at right now. So we're going to hit our call here. We're going to hit all these int3s that they have. This is annoying. Maybe I can adjust that. Default breakpoint. Like UD2 or something. Oh man, yeah, they have a bunch of fancy analysis stuff. Okay, we'll just knock these out. Finding them is gonna be a pain, but that's okay. Okay, we'll go into this call here. So they've basically inserted a bunch of, from what I can tell, it looks like they've inserted a bunch of like interrupt instructions, which are commonly used for breakpoints and debuggers, and it just basically gets in the way and stops the execution prematurely. Yeah, I just want to yeah, should I just set the rip at the shellcode? Because we don't really need it to be, I guess it needs to be an executable memory. Hold up, I might try that in just a sec. Okay, so we have our syscall, and then we have our memory allocation, and then let's go to our call here. And then this is going to be our entry point into the shellcode that we're analyzing statically. So this is just doing those pops and then calls. And then these are those relative calls. Is this really tiny? This is way too tiny for you guys to see. I wonder if the ret far is actually used there. Oh, for, yeah, I hope not. Because x64 or x64 debug can't handle Heaven's Gate. So I guess we'll see. Then we might have to use WinBag. All right, so let's figure out where we are here. So I'm gonna need to rebase. I'm gonna need to rebase this to the shellcode segment here. I'm gonna need to rebase it to the same as our memory allocation here. So okay, so let's dump this just so we're correctly aligned, and then I'm just going to reanalyze this with IDA, because so we can have the same memory alignment. Okay, and then we're going to open that with IDA. Nice, IDA found a bunch of functions on its own. And then let's rebase this. By the way, I think I definitely did like all of this with Binja last time, which is kind of funny. Segments, rebase, and then let's set the same address. I'm going to snapshot it here. In shellcode, let's say. By the way, do you use IDA or Binja's remote debugger at all? Mostly x64 debug, but I've used IDA's debugger quite a bit for like Linux and Unix stuff. It's really good. I should probably use it for Windows stuff more, but I'm just more used to using x64 debug. I haven't used Binary Ninjas yet, but I should probably give it a try. But I've heard it's not as good as the others, so I think that live debugging with IDA would speed up a lot of stuff here. Yeah, that's a really good point. Maybe I can do that for next stream, actually. I just don't want to like start setting up the remote debugger and stuff, but maybe I can do that. It's been a while since I took a look. Yeah, it's pretty good. It's they've come a long way, and it's definitely getting a lot better quickly. So, okay. So let's rebase this to this address, and then we're gonna be. It probably found some of these. Yeah, these hashing algorithms differ, I think. Okay, so this is the one that we found before. So let's break on this. I really need to set up my default IDA view, so I'm not doing that over and over again. So this is the. Okay, we don't have the xref to this function, but I think this is the hashing algorithm we want. So let's break, yeah, we don't have the xrefs to these because they're the weird calls. So yeah. So, okay, so let's break on this. All right. Okay, so this is gonna okay, so this is NTDLL. So why didn't my hashes work? Maybe I messed up the implementation. We can test this out though. So for example, if we have a SHA-1, was it a SHA-1 final? It's in the debugger right now. Yeah, a_SHA final. Okay, so like let's see if this is the same, because then I know there's probably a bug in my stuff. 539 4D BBE. I'm just gonna see if we can maybe get some help with AI here, because I'm probably missing something really dumb. I'm just gonna see what it comes up with here. A1. All right, let's try this. After every operation. All right, I can try that. So like even with these multiplications and stuff. Yeah, it's not even doing the bit mask, so that's probably a bad idea. With the mul and XOR, okay. More brackets, all the brackets. If you want to be bulletproof, you can try C type C and. Okay, yeah, that's a good idea too. 0. How did that happen? I think it's the same as before. F39. Okay, I'll try with these now. And then, yeah, that should be okay. D02. No, it's still completely different. D02, D0F2. Yeah, that's what I had before. 214EC. Sorry guys, I know this is kind of boring, but we just need to figure out this hashing algorithm. We can at least see in the meantime what this is resolving here. So I'm just setting breakpoints after the hashes match, and then ZW accept connect port, possibly. Oh no, it's RTL allocate heap probably. 14. Yep. Okay, so this is yeah, they're very different. Okay, let's try and do this again. Can you send a pseudocode? Oh yeah, I can do that. EA4C060LL. Long. All right. Okay, and then let's see what the other ones are. This is allocates a heap, and then we have another one here. ZW allocate virtual memory. Let's see. So this is passing this address, which is base of NTDLL. Yeah, I don't know what these bytes are being checked for, but I assume this is probably getting the correct offsets to something that it needs. Okay, we should probably create a struct here. So, man, I don't know why I don't have like that right-click menu item to drive a struct, convert to struct. Create, oh no, never mind, there it is. And then this guy is calling, yeah, I'm not sure what this is doing. I think it's copying out the Syscall code until it gets to specific bytes. I could probably open up a ZW allocate virtual memory in NTDLL, but okay. Get rel. Okay, yeah. Thanks, printsup. Okay, then it's passing that struct as the 1, 2, 3, 4th argument. Okay, so this is the, I believe. Okay, and then this is making an allocation of 3,000 bytes. And then let's see what else. Oh, we're in undefined code now in our shell code here. Okay, so all I did there was changed it to code and then made it into a function. So I'm just fixing all of these bytes that are not resolved. Okay, so let's look at this code now. I really just want to figure out what this malware is doing. I wonder if any of those other hashing algorithms are in hashdb2 printup, because it might have just been the first one that wasn't. Maybe I should try that. Let me just grab hashdb real quick. And then I know I'm gonna have to reopen IDA again, because of the plugin stuff. And I know I need to install requests. So I did this on my other laptop earlier. So, and then I need to reopen IDA from there, from my like activated virtual environment terminal. It's weird. Okay, let's see if those hashes are in HashDB. I think there's some more in here. I think this is all shellcode, so let's see what this is called. Stack. Unresolved stack offsets. Okay, let's see what these hashes are. If we can. Failed to parse value. Great. Ah, damn it. Yeah, I think so too. Man, this is so annoying. Maybe it's here on the left. I can do it. Can I do it from the disassembly? There we go. All right, BRC4. So is this BRC4? Are we reversing BRC4 right now? Okay, NT-allocate virtual memory. All right, prints up where I should look at that hashing algorithm implementation on HashDB to see what I was doing wrong. Just goes to show you should just use HashDB when you can instead of trying to re-implement these. Oh, couldn't find this one. All right, let's fix these up. I think that one wasn't in HashDB, but I'll double check. MW get Syscall. Okay, this is reused. This one should be in HashDB. Get DL handle X. Cool. Okay, this might be a different DLL. Yeah, it is. Okay, proc address. Load library. I don't know what this is doing. Oh no, this is hashing. Why don't you have this hash? Weird. This one's not in HashDB for some reason. Okay, so get proc address. Oh, thank you. Here, I want to try out your implementation. Let me pull it up. Oh, I don't think I have NumPy though, but I can install it. It's definitely the smarter way to do it. Building wheel. You return if there's arithmetic. Okay. Yeah, I like the cleanliness of NumPy, even though it has binary dependencies. While that's installing, I will continue reversing. Let's see if we can dynamically resolve this one. Maybe this code already passed. +1. I don't know if this is checking like those structs or something. Because checking these relative RAX offsets. Kind of weird. Okay, I want to see if I can dynamically resolve this one. Let's see. Oh, it's just resolving kernel 32. And this is just getting the, I think the end of the path. Let's see. Maybe just the length. Yeah. Okay. Loader get handle X. I don't even know what this API does. As usual for NTDLL functions, none of the following are documented. Okay. They're using it, so somebody must know what it does. DLL path. Okay, so this is just loading a DLL, I think. I think that's just loading. This loads kernel 32. And then get proc address, load library XA, and then let's see. I'm not sure what this while loop is for because these stack offsets are a little bit messy. These are arguments according to the disassembly, which is probably incorrect, but that's okay. Okay, this is like decrypting something here, so that's important. Okay, so maybe this is a config or something. Let's see. So it loads kernel 32, get proc address. Yeah, I think you're right. Okay, so this is that initial loop. So it's initializing a 256 byte loop. So is this just RC4ing? Probably. So okay, so we have our loop initialization. So our key scheduling algorithm, and then we have these byte swaps. Yeah, so this is probably RC4, but what's it decrypting? Let's see what it's decrypting. Yeah, I don't think it hit the code path. Okay, hold on, I'm just gonna reset this. And then we'll, so these are all like relative offsets. So, the 79 value, yeah, like relative stack offsets. Let's see if this is written to though. Okay, this is written to here. The 67 value. Okay, so let's go from the start of this function. I'm guessing if that hashing algorithm was used, this is probably BRC4, but be good to know one way or the other. I wonder if unpack me has BRC4. By the way, don't forget the type libraries might help with the secret. Right, yeah. What are those ones that we just added? Start with PHNT, yeah, this one. How can I force this to reanalyze? In NTDK, okay. Get the most recent one, and 64-bit. There we go, nice. That's a good idea. But okay. Yeah, I want to figure out what it's decrypting here. So this 220. So one of these is going to be the key, and then the ciphertext offset for the RC4. So stack 230. Can I like forcefully make this a variable? Like I know it says there's too many arguments, but change the stack limit sizes. I don't know how to do that in this new UI. Rename global item, set item type, edit functions, check the disassembler window, edit function. Yeah, there you go. Oh, nice. Thanks. Yeah. Okay. Local variables. Do we have a sub here? No. That's why it's all effed up. Oh, this is the preamble. That's why. How do I fix this? Okay, there we go. That should fix it. Did that? No, looks okay. I killed my pseudocode view for some reason. Okay, that should help a lot, having variables. Okay, so we have a call here, and then let me synchronize these. Okay. So now let's go to that loop. We still have some red variables, not entirely sure why, but okay, this is gonna be our S box. And then where's the key? I think it'll be this. Can you force decompile all functions? Yeah, I can. Produce file, create C file, right? Oh my god, these entitlements. Okay, there we go. All right, let's see if that does anything. Where was that string length call you mentioned? So 41, I think this is gonna be the key. Or 42. Okay, this is gonna be a struct. We can't automatically make it, unfortunately. Is getting a relative. Okay, so these are all of our. It's okay. We don't really need this right now. Man, all these got broken though. That sucks. All my hard work. That's okay. We still have all the enums here, so this is resolving. You can modify the type of the resolve function. Isn't that what I'm doing already? You can modify the type. Oh yeah. No. I understand what you're saying. The return value. I actually don't know what the enum's called. Let's see. Oh my god, this thing's huge. Yeah, this is why I do these streams, because I get all these good ideas from you guys. Because that's a really good idea. But it didn't affect the output. Did I do that wrong? I just all I did was oh no, wait, sorry, we don't want the return value here. Okay, we want that, and then I want the third argument. 1, 2, 3. There we go. Yeah, that's sick. Yeah, not the return. Third. Sorry, I'm getting tired. I know I shouldn't complain though, because isn't it like crazy late for you? Okay. All right, I want to figure out what this key is. I should probably fix these offsets though. I wish I could create a struct manually from this, but let's see. 35 int 64s. Is there a fast way to do this? Oh yeah. That's a good idea. Okay, now they're all variables. Oh, yeah, I know which one you're talking about. The Mandiant one, right? Okay, before I mark these up again, I I just want to see if this call path is not being hit in our dynamic analysis. Okay, no, it's not hit. Okay, let's see the, okay, SBox initialization round. Then we have, okay, so Rax is going to be, RCX is going to be, okay, let's see. Okay, I think this is our key. This DD thing, these bytes. And is this our config? Copy. Where's the notes for today? README, here we go. Just want to know if that's going to be the key. And then let's see if this is our config down here with the XOR. R11 is probably going to be our ciphertext offset. Okay, that's definitely decrypting. Okay, is this another key? Or maybe that's an IP or something. It's too big to be, maybe that's 2 IPs. Okay, let's see what they're going to be used for later on maybe. Okay, so RC4 decrypt 2 ints, and then plain text, and then the relative offset of the plain text minus 16 bytes is set into 74. Is this not used again? It could be struct offset. And then 55 is going to be our function table. Maybe we should have left it as the integer, right? But that's okay. 28 is going to be what? All right, it's probably our meat and potatoes here. It's probably going to do like command and control or something. Yeah, I need to make those function pointers back into a table because they're being accessed at relative offsets here. I can just dynamically do this since we're getting pretty late here. But I can't remember how big that array was that it was initially set to. Padding byte. Okay, there's, how do I fix this? That's all good, don't worry. It's all good. You know what I can probably do is do this with the past function table. J64 is the highest. Oh yeah, I guess show it, yeah. 12 functions, yeah. Because, well, then there's like V19, right? 58. So 50, and I think this is kernel 32. But I think I can just kind of cheat and then just generate a struct in Python. Yeah, that's a good idea. I was actually just going to do this because, so this call, right, which we're going to hit right now, will have the function table. So if I go, which one would it be? So it would be RCX. So here, and then these are function pointers, right? So if I just do like these relative offsets to that pointer, then I can resolve the address or whatever function is being called. Maybe this is a harder way to do it. This is probably the harder way to do it, but so if this is like the 0 offset of 55, then I can just do, let's see. I want to see what the code looks like again. Sorry, I know this is like the really slow way to do this, but that's okay. +2. So then like is this stupid? I'll just dynamically do it. So plus F0 plus 3C plus 50. Is this V7 initialized somewhere? See, so they're not like, they add them together. So this might be more of a pain than having like the actual integer offsets. Like these might not be one-to-one mappings. But can IDA do that for me? Oh no, function table, okay. All right, so, but like plus 256, right? Like that's more entries than I had. Because if I do like say, this plus 256, In the beginning of the module, base address and functions, then syscall indices. Oh, is that what this is? Where'd you see the syscall indices? Down here? Okay. So I think I might just debug this because my brain is dead. Okay, yeah, I understand what you're saying. It's the syscall instruction. Nice. All right, let's see. You saw the stage 2 code before that. They're scanning for the syscall instructions. Yeah. That's that was the code that I wasn't entirely sure about, but once you said that, it made sense. Okay, then this call is just like a mem copy from this v7 offset. Then another mem copy. I should probably get these offsets. Okay, I need to resolve those function pointers because that table is being passed around. Or, well, I guess it's more than just a function table. It's what you mentioned earlier. Ooh, this code is pretty complicated. All right, let's mark up these. So we have our destination, our index, source, length. Then we have, are these arguments not used here? Source. There's another struct. I think it's just getting the buffer size, but it should have that because it just did the memory allocation up here. So I'm not entirely sure why it's calling memcopy and then memcopy again. By the way, so you have the type loads of your named functions to their originals. Oh, cool. Okay. Yeah, maybe I'll try and resolve these functions. So is this shellcode offset? Yeah. Epic struct generator if you want to make the struct. Oh, cool. Thanks, printup. I will use this right now. So what's kind of weird though is like, I think even if we resolve some of these offsets, I'll focus for a second. What did you say earlier? Like 16 or something? 12 functions. Thanks for doing that because it was taking a long time. But like this function offset, I don't know if it leads to an actual function because it just led to a pointer within the shellcode. I think the limitation in IDA is that the compiler used some registers. Yeah, I think there's some of that going on too. I guess rename some of these high level ones. So MW, decrypt, RC4, and resolve funcs. So if I set this, or 55, was it? Oh, does it not recognize UN64? Like we said before, we know that some of the modules in the beginning function are just, yeah. Honestly, I would just eyeball it until things get right on the stack. Or let's just call this config table or something. Or func syscall table. I mean, we might have to adjust the size, but it's okay. Did it do 300? Oh, it's just the relative offset. That is my fault. All right, let's try this again. All right, that looks better. Oh, that's okay. I don't think we need like the member names like to be accurate. Like I'm just gonna rename them right now. So this would be the syscall. Okay, let's see if I can mark this up a little bit better now. But I would fix the number of parameters in the functions. That way the new lines aren't spammed. Yeah, I might just try and like not make it perfect right now and then just see if it's like readable once I pass this function pointer, if that makes sense. Just because it's taking forever. But the MW resolve hash. Yeah, it's like, I don't know. Maybe it's like, maybe I brute force things too much and readability should be my priority. But yeah, there's a lot more readable already, so they're missing. Or well, we're missing that information. That's what I was kind of mentioning earlier is like, these are larger offsets, but we have a function call, like correct function calls down here. So RTL allocate free. This is just cleanup though. This is like cleaning up and then exiting the thread. This call, this is the call that I was confused about earlier. So this will help a lot. 1, 2, 3, 4. 1, 2, 3, 4. RCX. Oh man, this is brutal. I feel like we're so close. But these function, or this syscall function table is being passed around. It's just like a giant pain. All right, let's try this one. So 1, 2, 3, 4, 5. Can you show which instruction is failing? Maybe you can fix it. Yeah. Here, let me just fix the function table for this function before I forget. Okay, load library. Good. Here, let me fix, let me break here, because we can at least fix these offsets. What do you mean it doesn't exist? All right, let's see what these are. Okay, we had that one already. What's it called? Load library on kernel 32 again. Okay. RCX, RDX, free console. 5C, 7EF. So this is okay, proc address, and then this one. I think it's just loading up a kernel 32 function table now, because it's R14 being incremented. Yeah. Load library. Oh man. What's the argc? Okay. MSV, was it DLL? MSV CRT, kernel 32 funcs. I just don't understand where these function names are coming from, but I'll probably have to like analyze the code closer. This is pretty brutal. Okay, so, and then this one is doing a, yeah, I'm not sure what this function does. Sorry, this is brutal. I don't really know, like, short of putting more effort into that structure with like substructures, I'm not entirely sure how to do this a better way than like just dynamic analysis and static analysis. Just because there's relative offsets that I'm not entirely sure what they're for, or that are accessible. If you guys have a better idea, let me know. But I think these are like nested structs, so it's pretty hairy. To be honest, dumpulator is the way to go. Yeah. Yeah, maybe we can do a dumpulator stream next time. All right, this might be unpacking something else. I think that's what it's doing. Definitely looks like unpacking. Okay. Well, we're like 4 hours into the stream, so 4.5 hours. So I might wrap things up pretty soon. I would like to figure out what the heck this is doing, but we can always continue this. So we're hitting this NTL, the stuff we already resolved. Now XC40 bug is, yeah, it definitely looks like it's unpacking another payload, which is currently running probably. And then I think it's maybe one of these callbacks, or sorry, maybe one of these syscalls. You can provide a callback for free one. Otherwise, you'll have to script it or do it manually. Yeah. Can Dumpulator handle syscalls though? Yeah, let's see if we can fix this function. Oh yeah, okay. Yeah, that makes sense. I don't know why this is this particular function is failing to decompile. Call analysis failed. So it's these call instructions that it's failing. Oh, cool. Okay, so add this address. What does it mean when it can't do the call analysis? Like these look like arguments that are being pushed onto the stack. Is this NOP that's effing things up? Okay. Yeah. And then the jump is, yeah. Yeah. I just don't know what it's calling here either. Yeah, that's what I just did. Yeah, that's the beginning of NTDLL. And then this is the beginning of kernel 32. Oh, there's our function table here. Can I Google this syscall number? Just a single step and you, okay. But like, how will I know what, or whatever, I'll just do it. Do you know what I mean? I'm like not sure. Okay, yeah. So is it F's? Or am I misreading this? Like it didn't fail, so Oh, 0x50. Is it Jiru who has the Syscall tables? Oh, cool. Okay. I'll just check your DM. So I don't know if I'm doing. Oh, anti-protect virtual memory. Okay. So it's doing, I think these are like, it's just modifying the section permissions in that while loop. Okay, so like, I think that this is just another unpacking step now. So like, did I just mess up that RC4 decryption earlier and this was another portable executable? I just want to double check that. Yeah, I don't know if it's, but I saw like a PE header earlier, so I'm just going to double check this RC4 call because I don't want to be wrong. Because if it's mapping each section just through syscalls, it's just like confusing me. So RBX to R11, so copy value. CD9 to D10, CD. So this buffer is actually 3BC0F in size. So yeah, I think I messed it up earlier. And this is bigger than I thought. R11. Like, I think this might just be headerless or something. And that's why I missed it. See how it has the PE, but it's missing the MZ. So if I can fix this, then maybe we can just recover the next stage. Because we want, I don't see any imports though. But maybe I'll just dump this and then we can take another look. Breakpoint on the executable pages. No, I went back to the RC4 step from earlier because I thought I missed something and I think I did. So, okay. So, file name. Oh, is it memdump? Is that what I was thinking of? No, it's save data. All right. So, okay. Yeah, so I had it mostly right. And then co.dump like that. What do you mean there's no function save data? It's literally the docs right here. Oh, is it because I didn't give a string? Yeah, what am I doing? My brain's like not working at all right now. Oh, is there no like arguments? Failed to write file. Okay, I think it just doesn't have permissions there, but if I get... Okay. How do I fix this? Yeah, I understand what you're, no parentheses. So I understand what you were saying earlier with the permission changes. Like that memory. Yeah, that's what I was thinking. Like let me open up another, maybe I got the start offset a little bit wrong. Because it's at hex 100 here. But this is a rich header too, so. Okay, let me get rid of all the crap before the PE. And then I'm just going to add all this crap before the PE. Because I don't think it matters. And then let's just see if it opens an IDA here. Just got to make sure the NT offset. The NT... Yeah. I'll make sure. If this doesn't work, I'll like put more effort into it. Another DLL. Looks like it mostly worked. More malware. Okay, maybe I'm gonna upload this to Unpack Me and see if there's any YAR hits. Even though I know it's like not 100% correct. But I think I might save this for next stream because this is more hashing stuff. Yeah, they just wiped away. Yeah. I don't know what that, like if you saw that load warning, this address. Yeah. I'm just sad that I missed that RC4 earlier. But it just didn't have a full PE header, so that's why I missed it. But yeah, I'm going to probably save this next one for next stream, but let's upload it and see if is my session still valid. But yeah, thanks for all your help, print up. It was a really big help. Messy business with the syscalls. And I'm like, the reason I chose this target was because it's something I'm not very used to. So hence the want to get better and stuff. All right, let's see. Syscall and Packers. Her pain. Is loadable? Yeah, I don't think it is. Encrypted data using RC4. So there's another there's like another RC4 layer in there too. But yeah, I don't know if I'd be able to like directly debug that dumped P. Maybe I could check that for next stream. But yeah, I think we'll probably stop there just because it's been 5 hours. Wait, if the dumped P, yeah, I just opened it in IDA. Is that what you meant, Prince Up? Like this is that dumped PE. See, it has like all this crap in it. More interesting things to look at. But yeah, I appreciate you all. Sure, you can open an IDA, but oh, I see. Okay, yeah. So yeah, loadable as in like loadable by the Windows loader. Yeah. No, I think you're right. It probably wouldn't run, but well, I can check if you want. But I don't know if it will. Plus, it has the notepad rich header. I don't think that matters though. I was open the wrong one. It looks okay. Exception is Stack Overflow. Maybe not. Check TSK. I think that's just part of the. Yeah, so I'll have to mess around with it. I think if I can get it to properly map into memory, like those Syscalls we're doing, then we'll probably be in better dumping shape than just like trying to reconstruct the header. But yeah, cool. Thanks for sticking around, Prince Up. And I don't know what's going on next weekend, but I might be able to stream again. We'll see how things go, but this will definitely be the next step. Hopefully there's not too many more crazy Syscall unpacking layers and we can get to the final binary. It might just be CACbot again. And this one just had extra steps. So, but the good news is if I can find that RC4 code, like that RC4 code isn't decrypted. So then if I can find the RC4 key, then I can automate that too. Or maybe it's not even worth that or automating that piece, but yeah, thanks so much for sticking around, everybody, and hope you enjoyed the stream. If you're not in our Discord, I'll throw an invite in here. Print Up, I just sent you invite. But yeah, if anybody else wants to join, there's our Discord. So the reason I can afford IDA 9 and all of these things is because we do this malware analysis training. So if you're interested in learning how to do malware analysis, there's not direct Syscall analysis like we were doing today, like more advanced stuff, but these are pretty good introductory courses for doing malware analysis. So if you're interested, check those out. But with that, I'm going to find somebody to raid. Even though I'm sure most of you folks are going to bed. Oh yeah, Cerberus is still up. So, but yeah, thanks everybody for sticking around. Really appreciate it. I'll see you soon.